Today we're going to look at simplifying and multiplying rational expressions. So this is one of the applications where knowing how to factor pretty straightforwardly is definitely going to help you out in this application. So if you do need some review on factoring or still unsure, again, keep in mind you can always write out your work. But this is one of the reasons why I've had you do so many practice problems, because it really is going to help you on these. So just as a reminder, we're going to be working with rational expressions, which in essence is anything that you could write as a fraction. So if we go back to the basics and think real quick about how we can simplify fractions, well, biggest thing is we always want to look for a common factor that we can reduce out. So for example, we have the fraction 4/10, 4/10, but both of those, I can take a 2 out of them. I can divide a 2 out of both the 4 and the 10. And when I do that, I'm left with 2/5. So we had the common factor of 2. So common factor 2. We can also do this with monomial expressions, although we won't see these quite as much. So we have 15xz and we have 20yz. So if I think of, again, what would be my common factor between those two terms? Well, between 15 and 20, both of those I could take out a 5. And we have xz and yz, well, we have a z in common. So if I factor out a 5z from both of those expressions, in the numerator, we'd be left with a 3x. And in the denominator, if we factor out that 5z, again, we'd be left with 4y. And so as long as I have that common factor, that simplifies out, and we're left with just the remaining factors, the 3x and the 4y. So we can do this with factoring expressions as well. So just keep in mind, you always want to factor completely. So this includes taking out any GCF and then factoring out into sets of parentheses before you start simplifying things out. So first example, we have a 5x, then we have 50x cubed plus 25x squared in our denominator. So a lot of times these problems, they'll give you a hint. So our numerator we can't do much with, but it's 5x. Could I potentially factor that out as a common factor in my denominator? Well, I could. And actually, could I factor out anything bigger than 5x? Well, both the terms in my denominator, 50 and 25, those are actually multiples of 25. And we have an x cubed and an x squared. So I could actually factor out from the denominator a 25x squared, leaving me with 2x. And because I'm dividing out or factoring out the entire term, what happens when we divide something by itself? Well, we'll have the expression 1. So keep in mind, even if you factor something out, you still have to have a placeholder. We can't have smaller number of terms in kind of our leftover expression. So I can still use that 5x. And in fact, I'm going to take this one step further. And this is kind of my mental step that I'd be doing. So you might not necessarily write this out. But in our denominator, 25x squared, well, that's really 5x times 5x. Now, if I also consider that 2x plus 1 that I had, well, now I have that common 5x in the numerator and denominator. So I can simplify that out. And that leaves me with, again, simplified out the 5x completely in the numerator, always leave 1 as a placeholder. In the denominator, we still have a 5x. And we still have a 2x plus 1. And so you might see it written as this in a final answer, but you could also see it with that denominator multiplied back together again, which would mean we are looking at 1 over 10x squared plus 5x. So again, either one of these would be a valid way to leave this solution. And I think in most of the practice problems you're going to see and on your lesson check, and I believe possibly on your test, you might see that factored version most often, but you could see it multiplied back together again for a final expression. Okay, example 2. Again, let's factor each one of our expressions completely and then see what simplifies out. So in our numerator, we have a 2x plus 18. I can take a common 2 out of both of those terms, leaving me with x plus 9. In my denominator, I can factor out that trinomial, but he's a pretty straightforward one. The first terms I know have to be x and x to get x squared. And so I just need to think of, well, what factors can I do with the 18 that would combine to make a 7? Well, I could use 9 and 2. And then if I think about my signs, trying to make a positive 7 in the middle, I'd want to use a positive 9 and a -2. And again, lo and behold, I have matching factors. I have an x plus 9 both in the numerator and denominator. And again, a lot of times the other part of the problem might give you hints if you're getting stuck as to which factors you want to try. So we can simplify out the x plus 9s, and then we're left with the 2 in the numerator and the x minus 2 in the denominator. All right, let's look at example 3. So again, a trinomial and a binomial. The binomial in the denominator cannot factor out, but it might give us a hint as to what factors we're looking for in the numerator. So 2x squared, well, I can break it down to 2x and x. 5 is a prime number, so I can only do 1 and 5. But let's think the placement of this. If I'm trying to make that -3 in the middle, I don't want to have the 5 and the 2 multiplied. That would get me up to a 10 and my numbers are going to be too big. So let's think about putting the 5 first and the 1 second. Well, again, double check your factors. I'd have a 5x in the middle and a 2x on the outside. Well, if I subtract 5x and add 2x, that gets me to my -3x in the middle. Denominator is already the 2x minus 5. And lo and behold, we have matching factors. These simplify out. So we're left with an x plus 1. And technically, whenever you completely simplify out all your factors, you do have a remaining 1 in your denominator. But think about that. What happens when you divide anything by 1? You just get itself again. So this would definitely be written as the solution, just x plus 1, fully simplified. Alrighty, example 4. Again, go ahead, this might be a good time, pause your video, try out example 4 and example 5. And here's your hint. One of these works and one of them doesn't. Try it out. Okay, let's see which one of these worked. So example 4, let's start factoring. So x squared, x times x. And then to get a 6 with a difference of +1, I'm going to use a 2 and a 3. If I add the 3x and subtract the 2x, that would give me the +x in the middle. Okay, my denominator. Again, I'm starting with x squared again, so just x and x. 10, well, I could do either 1 and 10 or 2 and 5. To make that 7 in the middle, though, I'm going to want to use 2 and 5. Okay, so let's see, to get the -7, I would have to do -2 and, wait a second, would that give me a -10 when I multiply my n terms back together again? Well, I can't change my terms to positive because that's not going to make the -7 in the middle. So actually, my denominator on this one does not factor. Unfortunately, that means I'm not going to have any other factors that I can simplify out with the numerator. So this is already simplified. Alrighty. Example 5 then must be the one that worked, but let's just double check. So again, factoring out the numerator, we have an x and an x. We have a -30, and we're trying to make a 7. Well, 30 is 3 times 10. So if I did a +10 and a -3, or +10x, -3x, that would give me my +7x, and then I have -3 times 10 makes that -30. But what's going on with this denominator? It almost looks like that first term, but the problem is my negative sign's in front of the wrong thing. So I can think of that denominator, and again, this is kind of my train of thought. You might not necessarily need to write this middle step, but I can think of this denominator as -x plus 3. Again, I kept the signs in front of the same terms. I just rearranged them because I'm used to seeing the x in front. And so what do you notice between the -x plus 3 and the x minus 3? How are they different? The only thing on there is the signs are flipped. So what kind of number could we potentially divide or factor out that would flip signs? Well, you did this last unit. When we had to deal with our absolute value problems, we had to think about both our positive and our negative. So technically we multiplied that right-hand side by a -1 when we solved those problems out. So let's kind of do the opposite. Let's factor out a -1 from our denominator. So factoring out that -1, that would flip my sign. So I'd have an x minus 3, and now my factors match. So if you see a subtraction, but your orders are flipped around, this is the trick you can use to make everything match up. Now I have x minus 3 factors in the numerator and denominator. I can simplify those out. And therefore, all I'm left with is the x plus 10 in the numerator and a -1 in the denominator. But I could also write this as, well, what happens when you divide things by a negative? I could write this as -x minus 10 and not have a fraction anymore. I have a feeling we're going to be able to do the same thing in example 6. The thing that's given it away for me is that -x squared in the numerator. So let's actually jump the gun because we haven't done any factorings with negatives in the front. So let's just go ahead and factor it out. So if I factor out a -1, that's going to leave me with x squared minus 2x minus 24 in the numerator. And I haven't done anything to the denominator yet. And so now that expression inside the parentheses looks a lot more like what we factored before. And so if we break that down, again, we have an x times an x for our first two terms. 24, let's see, I'm trying to make a 2 in the middle. So I want to make sure I have my factors pretty close together. I'd probably look at 4 and 6. To make a -24 when I multiply, one has to be positive, one has to be negative. And if I have a +6 and a -4, that'll get me, oops. We want to reverse that, don't we? This is why this method's called guess and check. You try filling things in, kind of mentally check it. If I'm going to take a 4x and a 6x and turn them into the -2x that I had in that previous expression, the 6 has to be negative and the 4 has to be positive. X squared minus 16, that's one of our pattern problems. So that's a perfect square. So x plus 4, x minus 4. And hey, we have a matching factor that we can simplify out. We're left with -1 times x minus 6 over x minus 4. And this is one of those scenarios, you could write this a few different ways. So I don't really like having that -1 sitting out, but this is not incorrect. You could also write it as -x plus 6 over x minus 4, or you could multiply it out on the denominator and have x minus 6 over -x plus 4. Again, lots of different ways you could write this out. Alrighty, so our second piece is multiplying, and the reason I'm doing this in the same video is because multiplying is really just a big simplifying problem. So if you think about, oops, we have a challenge problem. I forgot about that one. Go ahead, pause the video, try that challenge problem. Again, now would not be a bad idea to take a break if you need it. Okay, for our challenge problem, why do you think that's a challenge problem? We have 4 terms in the numerator. So this is one that we'd actually have to factor by grouping. So I'm going to do a little bit of side work here. So 2x cubed plus x squared minus 18x minus 9. If I group these up, I've got an x squared in common on the first group. So 2x plus 1. I have a -9 in common on the second group. And again, don't forget, if I totally factor out that x squared, that means I still leave a 1 in its place. Anything divided by itself always leaves 1. So then we have an x squared, hey, minus 9. We have another pattern. So I have to factor that out even further to an x plus 3 and an x minus 3. So this whole mess is just from the numerator. Or then the denominator has its own thing going on because we have that x squared term at the back. Well, that doesn't make sense. So if I rewrite that, I would have a -2x squared plus 5x, and there's another one of those with that leading negative that we never factored those. So if I factor out a -1, that would give me a 2x squared minus 5x minus 3. And now I can factor out my trinomial. I'd have a 2x and an x. Again, I've got to get a -3, but I have to come back to a -5 in that middle term. So if I do a 1 and 3, that would give me a 6x and a 1x. I can turn that into a -5 by doing a -6x and +1. And now I can go ahead and rewrite my original problem. So this whole thing, if I use my factors that I found for the 4-term polynomial, we have an x plus 3, an x minus 3, and a 2x plus 1. In our denominator in the red, we had a -1 times 2x plus 1 times x minus 3. And we have a couple of common factors now. So we have the x minus 3 in common that we can simplify. We have the 2x minus 1 that we can simplify. And we are left with x plus 3 divided by -1, which again, I'd probably rewrite that as a -x minus 3, so I don't have a fraction. And again, that is definitely a challenge problem. You probably will not see one that difficult on your test, but just in case, I mean, you know all the techniques that you need for this. Okay, so multiplying rationals, just a real quick reminder of how we did this with fractions, and then we just apply the same principle to polynomial expressions. So if we had 3/4 times 5/6, when you multiply fractions, in essence, you're just multiplying straight across. So we would do a 3 times 5, aka 15, and we'd do a 4 times 6, or 24. But we always want to think in terms of, hey, can we reduce this down any? And 15 and 24 do have a common factor of 3, so that's really 5/8. And we could have, if we wanted to, done this actually at our first step. There's a couple different ways, a couple different methods we could use to approach this. So I could have, in that first step, notice, hey, 3 and 6, well, 3 is a factor of 6. So I could simplify out the 3, leaving a 2, and then when I multiply straight across, I'd get 5/8. Both methodologies get me to the same end result. That being said, when we're looking at these problems with polynomials in them, we're always going to want to go with, let's factor this out and look for those factors we can simplify first before we just randomly start crossing things out. Okay, 4/8 times 24/5. Again, any common factors? Well, yeah, 8 and 24. Well, 24 divided by 8 gives me a 3. So then I can go straight across, 12/5. Much more quicker when I take out my GCF or take out my common factors first. Alrighty, example 8. Here we go. So always factor everything first. Keep in mind, I can't cancel from this step. So even though I have an n here, I cannot cancel anything with that n to the 5th. N to the 5th is a monomial. N minus 6 is a binomial. That n down below is kind of attached to that -6. So I cannot cancel in this step. So let's factor everything out. We have n to the 5th over n to the 6th. No common factors there, nothing else I can do with this. Multiplications, I can multiply numerators and denominators straight across. So I'm just going to write these as one big expression. N squared minus 6n. I have a common n that I can take out, which leaves me with n minus 6, which lo and behold, I have an n minus 6 already in the denominator. And then I have n to the 8th. So first off, well, let's cancel out the bigger factors. N minus 6 can simplify out. So let's think about what we have left. We have n to the 5th times n, aka n to the 6th. We have n to the 8th. So do we have any common factors that we can take out? Again, we're not used to thinking of this necessarily with just these monomial terms, but if you need to, think about how many of each you have actually multiplied. N to the 6 is really 6 n's all multiplied out. N to the 8 is 8 n's. So 1, 2, 3, 4, 5, 6, 7, 8. Again, I don't always write this step out, but this is what I'm always thinking. And so then again, I can only simplify out when I have a matching factor in the numerator and denominator. So I can just kind of go along, cross out the ones that match, and all I'm left with is those 2 n's in the denominator. So n squared. But again, if we canceled everything out of the numerator, what should we leave as a placeholder? The 1. And that's our final answer. Okay, example 9. Again, factor everything first. So first expression, x squared minus 5x minus 24. Again, I can start with an x and an x. See, 24, I need factors of 24 that could combine or have a difference of 5. So I'm thinking 3 and 8. If I subtract the 8x and add the 3x, that gives me my negative 5 in the middle. In the denominator, 6x and 2x squared. Well, I can factor out a 2x, which leaves me with a 3 plus x. Okay. Then again, since I'm multiplying, I can just put everything all together in one fraction as long as I keep all my numerator still in the numerator. So I have a 5x squared. And then I have an 8 minus x. So are you noticing anything from previous problem? I have things flipped around, don't I? So I can take, I don't have to worry about the x plus 3 and the 3 plus x. Addition is commutative, so we don't have to worry about switching those orders. But the negatives we got to be careful of. X minus 8 and 8 minus x, the signs are opposite. So what did we factor out to fix that? And we factored out a negative 1. So I'm actually going to rewrite this. So numerator, we still have the x minus 8. We still have a 5x squared. In the denominator, we still have a 2x. And I'm going to go ahead and also factor out a negative 1 from that last factor, which makes this x minus 8. And now I can cancel that factor. While I'm at it, I have a 5x in the numerator and a 2x in the denominator. Anything that can simplify out from there? We can simplify out one of our x's. And so then we're going to be left with just a 5x in the numerator. And in the denominator, we have a 2 and a negative 1. So I can just multiply out negative 2. And again, there's a few different ways I could represent this. I have a tendency to put my negative out front of the fraction, but both of these are still correct factorings. So it really doesn't matter how you write it, they're both correct. Alrighty, last two examples. Again, go ahead, pause the video, try these out on your own, and then come back and see how you did. Okay, let's see how it went. So first expression, x plus 3 doesn't factor anymore. We have an x and an x. Factors of 20 that are only 1 away would be 4 and 5. We do a subtract 5, add 4, that gives us our negative x in the middle. Okay, second fraction, which again, I'm just going to write these all as one big fraction. X squared minus 25 is a perfect square. He's x plus 5 and x minus 5. 2x plus 6, I can factor out a common factor of 2, which leaves me with x plus 3. And so now, as long as the repeat, I've got 1 in the numerator, 1 in the denominator. I can simplify out an x minus 5. I can simplify out an x plus 3. But what I have left in my numerator is an x plus 5. In my denominator, I have a 2 and an x plus 4. And again, depending on who's writing the problem, you might see it written like this, or you might see it written actually multiplied out in that denominator as a 2x plus 8. Either of these would be a correct answer. Okay, last one. Did you catch the flip? So if you notice in that first denominator, you've got a 9 minus x, and all the factors that we're usually getting are always reversed. So in my first step, when I'm factoring everything out, I'm going to go ahead and factor out that negative 1. Okay, first expression is x squared minus 16, which is a perfect square. So x plus 4, x minus 4. 9 minus x, I'm going to factor out a negative 1 to turn that into an x minus 9. And then factor my other fraction. So I have an x and an x. Let's see, to get that negative 90, but only a difference of 1, I could use 9 and 10. If I subtract the 9 and add the 10, that would give me a positive x or a positive 1x in the middle. And then in my second denominator, again, starting with an x. But see, 40, everything's a positive sign, so that helps us. If I did 4 times 10, well, plus 4 plus 10 gives me that positive 14, and it multiplies again to give me my negative or my positive 40. So then I can start looking for my common terms. I have a plus 4 and a plus 4. I have an x minus 9 and an x minus 9. I have an x plus 10 and an x plus 10. And the only things we are left with are x minus 4 in the numerator and a negative 1 in the denominator, which I could, if I wanted to, write as negative x plus 4. All right, as always, please, please, please ask questions if there were any steps in here that you didn't understand. Try out your lesson check and then check your results and ask about anything that you're not sure why you got it incorrect. See you later.